Okay, today we're going to learn very briefly about for loops. For loops, okay? For, F-O-R, for loops. So the concept of for loops is they're great for counting. So if you want to do something more than once, remember, one of the benefits of computers is that they're going to do the same thing over and over again. They're going to do it perfectly. They're never going to make a mistake. They're never going to get tired. They're never going to complain. And they will always do it exactly as you told them to do it. And the way to do the same thing over and over again is with what we call a loop. So there are a few different kinds of loops, but primarily we're going to talk about for loops today. And a for loop is a counting loop. And the reason they call it a for loop is because the word for, F-O-R, is the first word in the loop. So we go for. Okay, and then I'm going to leave these parentheses blank for the moment. And then in between the braces is the action. Now, what goes in the parentheses? You need three things. God bless you. You need three things to go in the parentheses. You need to tell it where to start counting. You need to tell it where to stop counting. And then you need to tell it how to count. So for this, we're going to start counting at 0. So we need to create a variable, and we're going to call it I. It's typical to call it I because I is short for the index, and there's a really good reason to do that, which we'll get into someday soon. But our variable is I, and it starts counting at 0. Then we're going to say stop counting when you get to 10. So we're going to say I is strictly less than 10. So start at 0 and stop when you get to 10. And then finally, how to count, and we're going to say add 1 to it each time. I'm going to put something here that's not typical, so you may want to write it down in pencil or write it down because we're going to erase it and change it. I'm going to write I equals I plus 1. The reason I'm writing I equals I plus 1 is because I want to count by 1. So when I run it, hello world shows up a bunch of times. Hard to tell how many times unless you actually count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll find out there are 10. But let's actually print the value of I. And then we'll see that it actually is 10 times, counting 0 through 9. And that shows us that we start at 0, we count by 1, and we go strictly less than 10. Question so far? So even though there's only one print statement on the page, we get 10 lines of output because our loop is happening 10 times. I'll give you a second to let that digest. Now, I told you I'd be changing what's over here in the last part of the for loop, and the reason we put I equals I plus 1 is because it's descriptive. It tells us add 1 to I every time and then reassign it back to I to keep track of our counting. However, there's a shortcut that C programmers like to use called I++. And you'll notice that the output is exactly the same because I++ says add 1 to I. It's a shortcut. It's a shorthand notation. It's just a way to add 1. It's called the increment operator. And if you put just a single plus, well, that's not going to work. We got a problem there because that's not the increment operator. And if you put 3 pluses, again, that's not going to work. That's not the operator. The operator is plus plus. And it might sound familiar if you've heard of the language C++, which of course finds its origins in C. And you can follow the metaphor. It's an increment above C in the eyes of the people who made it. Any questions so far about a very simple for loop? There's a great reason why you could have said start at 1. And you could have said go less than or equal to 10. And then our output will be 1 to 10. But there's a really good reason why we typically will start at 0 and we will count strictly less than 10. And again, just to tease it, we will learn that in the future. I won't tell you why quite yet. But questions about a for loop. So you can start at any number you want and stop at any number you want. And the effect is going to be the same. In this case, 90 through 99. Or, if you want, you can start at a number that's high and go strictly less than, or you can go less than or equal to 90, for instance, and then we can say minus minus, and that'll count down. And you don't have to do it you don't have to count only up to 10. You can count up to 100. Well, looks like this particular Replit, he doesn't like that very much. What's going on? Oh, because I put greater than or equal to. Silly. I made a mistake. I didn't change my control expression. So let's try that one more time. So did you see what happened there? That was an unintentional mistake, but it was instructive. Because I started at a number that was, and I said, make sure you are greater than or equal to whatever. Since that control expression failed, became false, it never actually went into the loop. So the loop will happen over and over again until the control expression is false. So in this case, there we go, and counting, and then at the point that the control expression becomes false, when I is no longer less than 100,000, it stops counting. Any questions, comments, complaints, concerns? Now you don't have to count by 1. You can count by anything you want to count. Oh, I meant to say plus 5. Looks like I broke it. Let's try again. You can count by 5s if you want. Interesting that that's happening. Oh, because it's 0 times 2, because I'm starting at 0. So once again, make sure that your step, your increment, see, I've created an infinite loop, because 0 times 2 is always going to be 0. So if you're going to do something crazy like multiplying in your step, make sure it actually makes sense. So start counting at 1 instead of 0. And now you're going to see multiplying by 2. Okay, so this is a for loop. Again, I'm teaching you how to use it, not when to use it or why to use it. The point is, you know how to make a computer count now. So you can put any code you want in the action, and we already know how to use ifs. So you can put an if in the action. You can say if, and then let's say we want to know every number that is evenly divisible by 13. All right? Every number evenly divisible by 13. So we would say if I mod 13 is equal to 0, then we will say printf and when we run it, we forgot to put our semicolon. And when we run it, let's put a little \n. And when we run it, we find out that 13 is divisible by 13. So it's 26, 39, 52, 65, 78, and 91. So it did the same if structure over and over again with a different value for I. Does it make sense? Any questions? Okay, so it's a simple concept, but until you practice it, it might be a little difficult to really put it to work for you. So I'll make sure and post an assignment on there that we can work on next class. And that's all I got. Have a great day.